We are solving a classic age problem with reciprocals today. We will translate the words into equations, solve the resulting quadratic, and then interpret the answer in context. Here is the story. Vivek is older than Kishor by 5 years. The sum of the reciprocals of their ages is 1/6. Our task is to find their present ages. Let's define our variables. Let k be Kishor's age in years. Because Vivek is older by 5 years, v equals k plus 5. Having those relationships makes it easier to work with the information that follows. Next, we translate the story into reciprocals. The reciprocal of Kishor's age is 1 over k. The reciprocal of Vivek's age is 1 over k plus 5, and the sum is 1 over 6. We'll also draw a quick visual that highlights the 5-year difference between k and k plus 5. We combine the two fractions on the left. The denominator is k times k plus 5, and the numerator becomes k plus 5 plus k. That equals 1 over 6. Cross-multiplying gives us another equation. 6 times 2k plus 5 equals k squared plus 5k. Now we expand and bring everything to one side to form a quadratic. We get k squared minus 7k minus 30 equals 0. This factors into open parenthesis k minus 10 close parenthesis times open parenthesis k plus 3 close parenthesis equals 0. The solutions are k equals 10 or k equals negative 3. Since age must be positive, we discard negative 3 and keep k equals 10. Now we use the relationship v equals k plus 5. Substituting 10 gives v equals 15 years. We should check the reciprocal condition to make sure it holds. 1 over 10 plus 1 over 15 equals 3 over 30 plus 2 over 30, which simplifies to 5 over 30, and then to 1 over 6. Everything checks out. Now that we have the ages, let's visualize them with actual numbers. Kishor is 10 years old, and Vivek is 15 years old. The difference is still 5 years, as expected. To conclude, Kishor is 10 years old, and Vivek is 15 years old. We used the reciprocal equation, solved the resulting quadratic, and verified that the reciprocals indeed sum to 1/6, just as the problem stated.